number 16, which says, write down the acceleration of the cyclist. So it gives you the graph, blah, blah, blah. What type of a graph is it? Speed time graph, okay? It's a speed time graph. And what are they saying? Speed of a cyclist journey is 30 seconds, okay? We don't read like we're reading a novel. Don't try to say, oh, they use a cyclist. Oh, he was, no, don't be funny. Come on. Speed in this journey is 30 seconds. Of course, we can see that. Either way, it's a speed time graph. We have it. Write down the acceleration of the cyclist between 15 and 25. So acceleration between 15 and 25. So 15 here to 25. That's here. What is the acceleration? So now let's talk about this. Let me tell you how to always answer graphs, and especially when it comes to describe questions that have to do with descriptions and this 1 mark question. It's so easy. You always ask yourself, when you get a graph, you ask yourself, who is the gradient of this graph? How many graphs do you have? This is math. This is the physics. This is the math version of physics. Okay, they'll ask you about distances and these other things in math, but it's simple things. The graphs which you can meet are a speed time graph and a distance time graph. So you can have a distance time. Let's put these 2 graphs. These are easy. You are old enough to remember these things I'm about to give you. You have distance versus time, and then you have speed versus time. Time is always the x-axis because time waits for no man. On a distance time graph, the gradient is speed. On a speed time graph, the gradient can't be speed again. A distance time graph is when it's speed. On a speed time graph, now it has to be someone else. And what is that? Gradient is acceleration. So acceleration is the gradient. You should put that. Always remember, this is the thought process. Who is the gradient of this graph? That's how we get this thing correct. The gradient of a distance time graph is speed, and the gradient of a speed time graph is acceleration. Now, let's see the second thing which you need to know is the types of gradients. Like, okay, I know what the gradient is, but now I want to know how do I describe each type of gradient? Now, you can have a gradient which is like this or like this. Whenever we see a gradient like this, we call this a constant whatever. Gradient, okay? This is when it's constant because it's a straight line. Your gradient is a straight line. It can be constantly positive or it can be constantly negative. So whatever you are dealing with is going to be constant. The gradient, that is. The gradient, when you are passing a point like this, you say it has constant, then you say the name of the gradient. Now, what is the other thing now when it's flat like this? This is not only straight, it is flat. For here, you say that the gradient is equal to 0. So there will be nothing of that guy. Then you're going to have now something which goes up like this, in which becomes more dangerous as you move up, or something which becomes more dangerous as you move down. This one is called an increasing gradient. Then you can have the same thing, something which now here. So this is an increasing. You can have this, or if it's a curve that's going down, it will be curving like this. Where you don't want to go down that thing. It's dangerous. Nobody wants to slide down something like this. No. But actually, for decreasing, it will be like this. It will be getting smoother as you go, and for this, it will be like that. So it's smoother, this or this. This is now for a decreasing slope. This is now for a decreasing. So are we together? Have you seen it? Have you seen it? Good. These are the words you use. Now let's go to the question. They said they want from 15 to 25. That's a flat line. Who is the gradient of a speed time graph? The gradient is acceleration. So if I want to know acceleration here, I use a speed time graph. So what is the gradient doing here? It's flat, which means it is 0. That means what is the acceleration between this? It is 0 meters per second. It's 0. Now let's go to part B and let's see what it says. By drawing a tangent, find an estimate for the acceleration at 7.5 seconds. So now let me just tell you. Here they want the tangent, but they want you to draw a tangent at 7.5. This is a game, even if they didn't tell you. If they say find acceleration, you know acceleration is gradient. And look at 7.5. Look at it. Look for 7.5. This is 5 and this is 10, which means 7.5 is right at the center, okay, of 5 and 10. Because we know that 75 is in between 50 and 100. So between 5 and 10, 7.5 is there. So how do you get a gradient of a curve? Because at 7.5, we are still in a curve. The only way to get gradient of a curve is to draw a tangent. In other words, you draw a line which touches your curve at that particular point. Okay, this didn't come out. This didn't come out nice. Let me draw another one. Something like this. A line which touches your curve exactly at that point. This is your tangent, okay? Then you now check for the gradient of that tangent. I'm going to go and pick 2 points, here and here. 2 points that are sitting real nice. And I'm going to go down to the x and see what value it is here on the x, okay? That means if this is 5, this is 5.5, 6, 6.5, 7, 7. So each is 0.5. So I can say 0.5, 1, 1.5, 2, 2.5, 3, 3.5. So this is 3.5. Then if I go here, it is 6. So 3.5 and 6. Then here I can go down like this. And this is going to be 10, then 10.5, then 11. So this is going to be 11. And here it is going to be 8. So that means I have 3.5, 6, and then I have 11,8. These are my 2 points. Now I will find the gradient using these 2 points. So I have to draw a tangent. If they'd asked me to say find acceleration at 7.5, you want the gradient at 7.5 because acceleration is the gradient of this curve. But then the gradient, you can only get it for nice lines. Here we have for a curve, you have to draw the tangent line, a line which touches your curve at one point. Then you find the gradient of that tangent. So you're now going to say, by drawing a tangent, find an estimate for acceleration. So you're going to say acceleration is equal to change in y over change in x, which is going to be equal to, here you can say x1, y1, then here you can say x2, y2, okay, x2, y2. But now for change, it will be y2 minus y1 over x2 minus x1. And what is this going to be? You can say it is equal to acceleration is equal to, for here, it will be what? y2 is 8 minus y1, 6. Over x2, 11, minus x1, 3.5. This will give us the acceleration. Let's put in our beautiful calculator because it can. So 8, make a fraction. 8 minus 6, we go down over 11 minus 3.5. She'll give you 4 over 15. So acceleration is 4 over 15 meters per second squared. There we go. This is square meters, so you don't have to put the square meters. It's already there. S to the minus 2 is the same as per S2. It's the same thing. So it's like to say this is 4 over 15, which is like 0.2. If you want to put it 0.267 meters per second. This is our acceleration. Done. Then now we're going to go to do part C, which we'll do in the next video. Goodbye for now.